So today is the so today is the new topic, digital image processing. Uh, okay, go through. Get 2024, the Geomatics Engineering new topic, part 2, digital image processing. Then we move forward the digital image processing technique. There are so many objective and so many table of content. At first we have discussed about the image correction, then we discuss about the image enhancement and discuss about the image transformation, and we discuss about the feature of selection, and we discuss about the classification, change, direction and application. So there is the image display. We have to see that there is so many band. The first band one is the blue wavelength, and second band was the green wavelength, and band number 3 red wavelength, and band number 4 near infrared wavelength, and band number 5 is the short wave infrared. We can see that there is the 3 band combination, blue, green and red band, and we have to see that there is the image display system. Okay, then display remotely sense image. We have to shown that the false color composite, natural color composite and grayscale image. So the color composite definition is the to display any satellite image in your colors, we need to select corresponding to red, green colors. So we have to see that the wavelength, we have to see that the blue color wavelength is 0.4 to 0.5 micrometer, and green color wavelength 0.5 to 0.6 micrometer, and red color wavelength 0.6 to 0.7 micrometer. Standard false color composite, the green color convert to blue color and red color convert to green color, and near infrared wavelength convert to red color. So there are the false color composite standard FCC. The color combination change, the blue change to green, green change to red, and red change to near infrared wavelength. Same green change to blue, red change to green, and near infrared change red. Why are you ignoring blue band? Because the blue band are the standard false color composite. Blue color represent by water body and any lake and any river area. Okay, any stream and any river area. So we can see that the one curve is here. This is the smaller 2 is the higher. Then we have to see that the smaller one, this is the 0.7 micrometer, and this is the higher portion is the infrared and red portion. This is the short wave infrared portion. Okay, then we have to natural color composition. Natural color composition never to change the any color composition and any wavelength. So we have to see that there is the blue color composition, and is the blue color composition is the blue color, green color composition and the green color, and red color wavelength is the red color. The image display system, the natural color composite system is never to change the color combination. Okay, then we have to natural color combination. We have to see that one satellite image is here. There is the several part of shown the image. We have to see that there is the water body and land area, and this is the blue color composition, and we have to see that this is the cultivate area, and it's a non-cultivate area, and sand area. We have to see that there is this white portion is the water body sand area, and we have to see that there is the several vegetation area, cultivate and rural area. Okay, we have moved forward. This is the gray scale image. So we have to see that there is the grayscale image, three type of color combination is here. First one is the blue color, second one is the green color, and third one is the red color. So there is the image display system is the color combination of the gray scale image. So we have to see that there is the color combination, and three color combination system is the blue, green, and red color. Okay, then grace color image we have to the same as the we have to before the scene. There is the grace color image is the then satellite image. This image show that there is the grace color image. The gray color image is the show that every portion, every features like gray color. Okay, then we have to move forward the contrast. Okay, the contrast mean it is the difference in the intensity of the object of the interest compared to the background. So contrast we have to know about the background and say object background. The contrast does not change linearly. The contrast does not change linearly, and it is the function of the logarithm of the difference in the object and background intensity. So contrast change the image background and image intensity. This means that the darker region small change in the intensity can be noticed, but in the higher region is the difference has to not much more. So contrast even when a image change to the contrast, then the darker region small change intensity is bit change, and we have to notice this. But brighter region, and when we change the contrast, then not difference any much more the darker intensity change. Okay, so we have to see that this is the global, local, and point operation on the image. So this is the global operation not consider location, and x and y is the image pixel. Any image pixel x y not consider the location, and small g equal to capital G, and f h any the capital H is the any operation of the image f, and whereas local operation also consider the pixel location in the processing. And g1 this is the, and h equal to this is the h I j k is the position of the band combination by band information about the pixel. And local operation are important when the illumination condition is the different across the image. Okay, the point operation are used to the enhance any particular pixel based on the gray level. So you have to point operation the particular pixel based on the gray level is the point location. So there is the several band combination I, J, and K. I, J is the position of the band information and band pixel. So there is the band pixel and band pixel and band information is the here point operation on the image. Okay, so we have moved forward the linear contrast test. Linear contrast means when a image remotely sends image with the poor contrast will have to less gray level than is the display range of the range system. So is the there is the O is the input, and I equal the digital number. So digital number gray level 0 to 255 255, because there is the L8 equal to 8-bit image show the 0 to 255 digital number, then 7-bit image show the 0 to 127 and digital number. Okay, so there is the we have to show that this is the histogram and curve, and this is the digital number, and this digital number shown that is the horizontally, and frequency is the histogram show that this is the vertically. So this is the one formula. O maximum number and minimum number greater than the input number maximum minus minimum. So there is the linear contrast stage and formula. We have to show that there is output maximum minus output minimum greater than input maximum minus input minimum. Okay, the linear contrast stage is the linear same is here negatively squared histogram and positively squared histogram. There is the two histogram is here positive histogram is the darker image and the negatively squared histogram is the brighter image. I represent the input image and O represent output image, and low contrast image can be linearly enhanced using different contrast stretching and techniques. Okay, then we have to see that this is the linear contrast stretch. Linear contrast stretching can be defined the output maximum minus output minimum divided by input maximum minus input minimum and into x minus input minimum. Okay, so wherein the this is the output maximum minus output minimum divided by our input maximum minus input minimum. So we have to last one, the y equal to m x minus 1 minimum. So there is the m greater than 1 is the stretching and m less than 1 is the compression, and m1 equal to is the line, and o represent by output maximum represent by vertically, and input minimum and input maximum represent by horizontally. So I equal to represent input image, o represent by output image, and m represent by slope of the line. So y equal to the main output is here, y equal to slope of the line into x minus input minimum. Okay, the x is the input level or y is the output level, and 0 to 255 in the digital number. So output maximum 256 and output minimum 1, and input maximum 186, input minimum 0, and for x equal to 55 and 200, and what will be y. So we have to move forward. This is the linear contrast stretch. This is one side. We have to see that there is the left side is the input pancometric image, and this is the after contrast stretch. When we have to the satellite image, when we linear contrast stretch, then we have to see that this image is the after linear contrast stretch. Okay, so there is the several changes here. This is the gray value is the more darker and more visible to after linear contrast stretch. Okay, then this is the linear contrast stretch is the input FCC image, false color composite image, and after the linear contrast stretch, the false color composite image is the more darker and more visible to our human naked eye. Then this is the negative image. Negative image shown that the your output maximum minus input, and y equal to 255 minus x, and 8-bit image for 8-bit image, and 7-bit image to 127 minus x. Negative of the image is the inverse of the image gray value with the respect to the image and quantization level. Okay, this is the quantization level of the negative image, inverse image gray value with the respect to the image quantization level. And negative of the image is the inverse of the image gray value with respect to the image quantization level. So input image and negative image, the several difference is here. There is the output maximum value minus x value. For 8-bit image 255, 8-bit image the maximum value is 255, and x value is the x value thus represent by the negative image. Okay, this is the non-linear stretch system, the films, computer, monitor, television, human visual system. So non-linear stretch is the several features is here, like film is the one example of the non-linear stretch, computer monitor is the one example of the non-linear stretch, and television is the one example of the non-linear stretch, human visual system. Okay, to analyze the object in the remotely sensed image, and linear contrast stretching techniques are not very useful. So non-linear stretching is the contrast stretching techniques is not very useful. So there is the logarithm stretch. Logarithm stretch is the non-linear technique where low range brightness is the enhanced, and the logarithm stretch is useful for the enhancing features like the darker parts of the original image. When we have to not seen that the darker portion, then we have to stress the nonlinear types. So there is the logarithm stress is the one formula is here, like y equal to k log and 1 plus x plus c. So there is the natural of the log curve, a rapid rise in initially and levels of the later, and for small gray value is the great difference, and for the large gray value of the smaller the difference. Okay, there is the logarithm stage is the maximum and output and minimum value. This is the lower portion is the output minimum, and higher portion is the output maximum, and the point of the input minimum, this is the point of the input maximum. So there is the one image is shown that this is the black very dark portion, the black portion is the blue portion, this is the water body, and we have to see that there is the gray value, the rural area and industrial area is the here. This image shown that the logarithm stretch, we have to seen that very clearly the structure, and this is the shape this image. So the logarithm stage and non-linear stage is the very useful for the image system and image identifying the features, okay, and object. This is the this is the exponential stretch. The exponential stretch is the opposite of the log stretch, and the enhance the details in the brighter portion of the gray scale. So there is the opposite log stretch. So we have to see that there is a log stretch is the value of the darker portion is the more darker, and brighter portion the more brighter, but this is the brighter portion of the grayscale, and the enhance the details of the log stretch, this is the brighter portion. And this is the one formula is here, y equal to k into xr plus c. The experimental curves rise much faster for the higher value of the argument of the experiment and x. The piecewise enhancement, the input grayscale is divided into the several subject range. The several subject range is the here. Different enhanced technique may be applied to each sub range, and it requires pure knowledge of the grayscale range of the object. This is the several piecewise enhancement. So the one image so that the every piecewise the grayscale range and the object. One object is the x1 to x2, and one object the part wise the x2 to x3, and one object the part wise the x3 to x4, and one object shown that x4 to x5. Thresholding, the a threshold for the output gray levels are used to the map and highlighted a particular object. More than one threshold value can also be used. Capital Y equal to small y1 for the x less than t, and capital Y equal to small y2 for all other value of the x, or if the gray levels range is known for the object, capital Y equal to y1 if capital T1 less than x and less than T2, and capital Y equal to the small y2 otherwise. This is the thresholding operation is here. The thresholding operation is the t equal to 48, and we have to see that this is the more darker portion is the this image, because the thresholding operation is the white to black portion is the image shown that. The density scaling is the and the advance from the threshold techniques. A separate threshold is used for the every sub range of the gray value, and capital Y equal to small 1 y, and if 0 less than x, and this is the less than t1, and y small y and the small y2, the if t1 less than x and less than t2, this is the capital Y and capital M if tm1 and less than x and less than tm. This is the density slicking. The density slicking is here. This is the histogram, and the shown that there is the the horizontally shown that this is the 200, 300, 400 and 500, 700 and 700. the value is the histogram, and we have to say seen that there is the vertically 0 to 5000 is the histogram densities and density slaking. So there is the highest value is the 500 plus, and the lowest value is the 0 to the 700 0 to 02. Okay, so this histogram is the several part of the several part. The one part is the 200 to 300, and the most of the peak is here 300 portion, and most of the lowest portion is the 700 to 0 to 100%. Okay, then is the density slaking is the one image the gray value and the black portion and white portion, and one image the density slaking into the 6 classes like the blue, green, red and yellow, and several parts of uh, missing this here. Okay, this is the density slaking one satellite image like this is the input image and the density slaking of the 5 classes. This image show that the blue and water body is the blue color, and the same wise the land surface covered to the blue color, because this water body and the land surface is the matching the density slaking in the 5 classes. Okay, so we have to move for of the lookup table. The lookup table in this is method of the conscious enhance the operation are the implemented using the lookup table of the input image input x0 to l1 and output image y0 to l1. Advantage: the original image information is the preserved in the lookup table. Original image information is the preserved in the lookup table, and this is the histogram based enhancement and histogram equalization. So dynamic range of the gray levels are the preferred to the better display. Dynamic range of gray levels are the preferred for the better display, and histogram equalization method image and the transform in the such a way that all of the gray levels have the equal likelihood of the occurrence. And histogram based enhanced technique consider the relative frequency of the occurrence of the gray levels. High frequency gray levels should be given the preferential treatment so that they should be well separated on grayscale for better display quality and optimize the utilization of the available display range. This is the merge gray levels having very few pixel and separate having the populated gray levels. Okay, so we have to see that this is the histogram equalization, and ideal in histogram will have the equal population of all gray levels. This is the input image histogram, and this is the equalized histogram. When we have to seen that there is the second part of the equalized histogram, the several part of the extend the histogram image, and we have to seen that this is the histogram equalization and image quality. So last one is the histogram equalization method. So CDF is the cumulative distribution function, and m into x is the image number of pixel, m and l is the quantization level, 8 bit, 16 bit, 7 bit, and dn value equal to the digital number. And we have to seen that there is the round of CDF, and this is the u and the CDF minimum, and the m into n the number of pixel, and CDF is the cumulative distribution function into l minus 1. So this is the row and column several parts of the like 63, 61, 62, 60, 51, 43, 53, 77. This is the one image pixel and digital number of the value. Okay, this is the histogram equalization, the dn34. This is the df2, cdf2 equalized value 0 and dn value 59, df হচ্ছে 10 and হচ্ছে cdf হচ্ছে 68. Equalized number is a 119. So this is the equalized values change the several part of the 10 to 75 and 68 to 144. So this is the one image low contrast image histogram equalization image. We have to see that there is the mountain area and we have to see that the like the several tree and several the vegetation area and flat land surface. The low contrast staging, the one side is the NCC natural image composition, and the other side the image abstract or histogram equalization. This is the FCC image, this is the histogram equalization, and last one, this is the one image low contrast image histogram equalization image. This is the one hilly area, and we have to see that there is the so many built up area is here. We have to see that there is the clearly the vegetation is the more green and the built up area is the more clearly we have to see our naked eye. So thank you. This is our the short and very few content is here. The DIP density slacking and here linear non-linear concept is the clear this video. Everyone see this video. Okay, thank you.